Question related, MCQs related to the topic electrolysis. So which statement about electrolysis of concentrated copper to chloride are correct? So again, when you are doing electrolysis, the first thing what you have to do, you have to write the equations. You should understand that what will happen during this electrolysis. So we have what we have concentrated copper to chloride. So concentrated copper to chloride means means more salt. As the term concentrated means it will have more salt, we'll have more copper sulfate, and we will have copper chloride, and we'll have less amount of water. So copper ions are there, sulfate ions are there, hydrogen ions are there, and hydroxide ion. I will just draw this so that you understand the concept. Directly you can also answer, work out, but we have electrodes. They did not specify it. If they do not specify that what material electrodes are made up of, so your consideration is always either it will be made up of platinum or graphite. The one which is connected with the positive terminal is anode, the one which is connected with the negative terminal is cathode. So copper ions are there, chloride ions are there, hydrogen ions are there, and hydroxide. For positive ion, what is the criteria? For the positive ion, we always check reactivity. That is the correct criteria for the positive ion. So which positive ion will move? The copper. That's good. So basically the copper ions are attracted towards the cathode. So as the copper ions are attracted towards the cathode, they will take 2 electrons, it will turn into a copper atom. And in terms of electrons, the negative terminal, electrons will come, and this copper ion gain electron. So copper ion is gaining electron and it turned into a copper atom. Then for negative ions, here by mistake I wrote sulfate. It is chloride because it's a copper chloride. So when we check the negative ion, the chloride ions are there, which are more in the solution, so they will move towards anode. So the equation for anode, when 2 chloride ions are there, they will lose 2 electron and it will turn into a chlorine molecule. So chloride ion are losing electron, turn into a chlorine molecule, whereas copper atoms are gaining electron and in turn into copper ions are gaining electron, turn into copper atom. We have to check which statements are correct. Electron are transferred from cathode to copper ion. Yes, that's true, because electrons are there at the cathode, they're transferred to copper ion. So statement 1 is correct. Electrons move round the external circuit from cathode to anode. That's wrong. You can see electrons are moving from anode to cathode. That's why this is also wrong. Chloride ions are attracted towards anode. That's true, because they're more, so that's why they're able to move. Hydroxide does not transfer electron to cathode. Actually, the statement is wrong because hydroxide is not involved here, and they're not transferring to cathode, they're transferring to anode if it was moved. So which statements are correct? Statement 1 and statement 3 are correct. That is why A is the right answer. Is it clear, this question? Any doubt in question 11, that how we work out the correct statements? In question 13, aqueous copper 2 sulfate is electrolyzed using carbon electrodes. So we have carbon electrodes. In exam, you don't have to draw the in exam what is the how you will work out. You will simply, because carbon electrodes are there, so we'll follow the procedure: copper ions, hydroxide ion, and this is sulfate and hydroxide. For positive ion, we check the reactivity. So copper ion will move towards cathode, and for negative ion, we check amount. Sulfate, carbonate, and nitrate never move, so the second ion will be hydroxide. And whenever hydroxide will move towards anode, the equation for hydroxide, because when four hydroxide ions are there, they are losing four electron and give us oxygen and water molecule. So the product at the positive electrode or anode, that will be oxygen, and the product at negative electrode or cathode, that will be copper. So C will be the right answer. Is it clear discussion? The electrolysis using the inert electrode of carbon. You can also draw the electrolytic cell for your convenience. This is an electrolytic cell. These electrodes are made up of carbon or graphite. You have copper ions, sulfate ions, hydrogen ions, and hydroxide ion. This one is a cathode, and here is a anode. So for positive ion, what is the criteria? We check the reactivity. So copper is less reactive, that will move towards cathode. So when we write the equation at cathode or negative electrode, cathode is a negative electrode. The copper ions are there, they are attracted. They will gain electron from cathode and it will turn into a copper atom. So for negative electrode, we should get copper, and only one option is with having copper. So C is there, so that's why directly C. But we can also write equation: sulfate, carbonate, nitrate does not move, so only ion which is left is hydroxide. So hydroxide will move towards the anode or the positive terminal, or positive electrode basically. So what we have because hydroxide ions will move there. So when there are four hydroxide ions, they will lose four electron and it will give oxygen as well as the water molecule. So whenever hydroxide ions are moving there, the result oxygen gas, so we'll see colorless gas or bubbles. That is why C is the right answer. Is it clear? Another question. The diagram shows a circuit used to electrolyze an aqueous copper to sulfate solution. Which arrow indicate the movement of copper ions? Copper ions are positive, which are there in the electrolyte. So which arrow is representing, 1 or 2? So 2 is representing the movement of the copper ion. So it can be C will be answer, or C can be answer, or D. What about the movement of electron? Electron always coming out from the negative terminal and moving towards the positive terminal. So what is the movement of electron? Which arrow is correctly showing the movement of electron? That is 3. So it is 2 and 3. That's why C is the right answer. Is it clear, this question? We have concentrated copper to chloride solution. So the term concentrated means more salt is there. So in the solution we have copper ion, we have chloride ions, we have hydrogen ion, and we have hydroxide ion. The salt is more and the water is less. For positive ion, we checked always the reactivity. So which is less reactive, as we discussed previously, that copper is the less reactive, so copper is attracted towards the negative electrode, or also known as the cathode. So when copper ions are there, they will gain electron from cathode. It will turn into a copper atom. So when copper ions turn into a copper atom, the copper ions turn into a copper atom, so they will stick to the electrode, the solid, because copper metal is a solid, so that solid will stick. So as that solid will stick, so what happened to the negative electrode? Its size will increase because the copper ions from the solution are attracted towards them, towards that electrode, and turn into a copper atom. So what happened to the size of the cathode? As solid is formed, the size will increase. But electrodes are made up of copper. So what happened at anode? The copper atoms which are there, they will go inside the solution as copper ion. So copper atom turn into a copper ion by loss of electron. So what happened to the size? Because the atoms are turning into ions, so the size of this size of the anode will decrease. So the positive electrode side, what we observe, it will decrease, and the negative electrode size will increase. That's why B will be the right answer. Is it clear, this example? The question? That is similar to doing the electrolysis of copper sulfate solution. So what we have, as you can see, we have the electrolyte. Why the size of the positive electrode is decreasing? Because the number of the atoms are decreasing. So example, if I say this is made up of 4 copper atoms, this is also made up of 4 copper atoms. So these are copper atoms. Because they mentioned that anode and cathode are made up of copper. Then the electrolyte, the solution, is copper. In this question, it is concentrated copper chloride. So it contains copper ion, it contains chloride ions, it contains hydrogen ion and hydroxide, because solutions, it dissolve in water, so water contain H and OH ion. So there is a copper ion, chloride ion, hydrogen ion, and hydroxide ion. These are the ions present in the solution. For positive ion, we check, this is a cathode, electrons will move, more electrons are there. So the positive ion, we check the reactivity. So these copper ions which are there in the solutions are attracted towards the electron. So what happened at copper ions gain electron, turn into a copper atom. So when these copper atoms are formed, they stick to this cathode. So when the copper atoms are formed, and they stick to the cathode, what happened to the size of the cathode? The size will increase. So that is the reason for increase in size, because the copper ions are turning into a copper atom which stick, and as they stick a solid is formed. That's why the size is increasing. But why the size of anode is decreasing? Yeah. So why the size of the anode is decreasing? Because the copper atom is going inside the solution as copper ion. So as amount of copper atom decreases, as the number of the copper atom decreases, what happened to the size? It will reduce. So at anode, the copper atoms are turning into copper ion. And at cathode, the copper ions are attracted. That's why the size of cathode will increase and the size of anode will decrease. Is it clear? Anyone having a doubt or a question? Another question: electrolysis of copper 2 sulfate can be done by using either a carbon electrode or copper electrode. So you will find many questions related to this topic, like electrolysis using carbon electrodes and copper electrodes. So if we have a container, and we are using two types of electrodes. The first case we are using carbon, the second case we are using copper. So this is a positive, negative, and same way positive, negative. So this is copper, here also copper. This is carbon, we don't have to write because they don't react. What are the ions present in the inside the solution? It's a copper 2 sulfate solution, aqueous. So it's a copper ion is there, sulfate ion is there, hydrogen ion is there, and hydroxide. Same thing here, copper ions are there, sulfate ions are there, hydrogen ions are there, and hydroxide. Uh, this is a positive terminal, negative, positive terminal of the battery, negative. So electrons will come out. Here also electrons will come out. Now, what happened for cathode? The copper ions, because they are less reactive, so they are attracted towards the cathode. So copper ions are there. They will take two electron and it will turn into a copper atom. So when it will turn into a copper atom, it will form a brown solid that will stick to the cathode. And what will be the equation for anode? Because these are carbon electrodes, so for negative ion we check the amount, but sulfate, nitrate and carbonate never move, so hydroxide ion will move there. So when hydroxide ion will move there, 4 hydroxide ions, they will lose 4 electrons, give oxygen and 2 water molecules. So at anode oxygen is produced, at cathode copper is produced. What about this one? The copper ions are attracted towards the cathode. The equation is same, copper ions, they will gain 2 electron and turn into a copper atom. But what happened at anode? The copper atom will go inside the solution and turn into a copper ion. So the size of the anode will decrease. The anode size will start to decrease and the cathode size will increase. And what is the equation for anode? the copper atoms turn into a copper ion by loss of electron. That's when we are using copper electrode, and this is when we are using carbon electrode. Now we have to check the statements. Which statement describe what happened at positive electrode or anode? So at anode, copper is deposited. Look, copper is positive ion. Copper can never be deposited at anode. Copper is not collected at anode. So even A and B cannot be an answer because copper is deposited. If the electrode is made up of copper, carbon or copper, that's wrong because copper is a positive ion, so it can only be deposited at the negative electrode. Then oxygen is produced if the electrode is made up of carbon. You can see when we are using a carbon electrodes, oxygen gas is produced. That's why C is the right answer. And oxygen is produced if electrode is made up of copper. That's wrong. Oxygen is not produced at anode. Basically, copper atom turned into a copper ion when we are using copper electrodes. Is it clear? So the first case we were using the carbon electrodes, and the second one we are using the copper electrodes. Any doubt in this question? Now the structure questions related to this part. In question 2, hydrogen can also be formed, can be manufactured by electrolysis. The electrolyte is a concentrated aqueous sodium chloride. So if we have concentrated aqueous sodium chloride, the term concentrated aqueous sodium chloride, it means it will have more salt and it is having less water. More salt means more NaCl and less water, H2O. So there will be sodium ion, chloride ion is there, and hydrogen ion and hydroxide ion. If they did not mention the electrodes, so electrodes are made up of carbon or platinum. So the negative terminal is called cathode, whereas positive terminal is known as anode. Electrons will move out from negative terminal of the battery towards the cathode. So the ions which we have sodium ion, we have chloride ion, we have hydrogen ion and hydroxide ion. So what is the observation? Which ion will move? For positive ion, the criteria we check the reactivity. Which is less reactive? And for negative ions, we check the amount. So which is less reactive? Is it sodium or hydrogen? So hydrogen is less reactive, that's right. So this hydrogen ion is attracted towards the cathode. So what will be the equation, half equation for cathode? That the hydrogen ions are there. They will take electron, gain electron and turn into hydrogen atom. But because hydrogen is a non-metal, so when two hydrogen ions are there, they will gain two electron and it will form hydrogen gas. And whenever something gain electron, we call that as reduction. So this change is a reduction. And we'll observe bubbles. The colorless gas or bubbles are seen. And what happened at anode? For anode, we check the amount. For negative ion, we check the amount. The one which is more, as you can see, it is a concentrated solution, so, or a brine, which we also say. So more chloride ions. So chloride ions are attracted towards anode, and they will lose their electron, which travel out. So when one chloride ion is there, it will lose one electron and it will form chlorine atom. If two chloride ions are there, they will lose two electron and it will form chlorine molecule. So whenever chlorine molecule is there, this change is called oxidation. And chlorine molecule, it means it will be a yellowish green gas. You have to learn these things, you have to memorize these things. The color changes, the color of the specific substance. And what happened to electrolyte? What happened to electrolyte? What is left? So we are left with sodium and hydroxide. So the electrolyte will turn into sodium hydroxide, which is also known as the base or alkali. It can change the color of indicator. First thing they're asking, define a term electrolysis, and it's of 2 marks. Today, inshallah, I will share with you all the definitions throughout the course, which you have to learn or memorize. Better memorize those definitions. So what is the definition of electrolysis? Basically, it is a process of passing current through a molten or aqueous solution. So when we pass the current through a molten or aqueous solution, we call that as, or breaking down the substance, or breaking down the compound into ions by using the electricity. So process 1 mark is for mentioning passing current or passing electricity or electric energy. And the second mark is for mentioning molten or aqueous solution. That's why it is of 2 marks. Name a substance that can be used as an inert electrode. So which substance can be used to make inert electrode? So it can be platinum or graphite. Even you can mention carbon, you can mention graphite, or it can be platinum. So these are the possible answers. Carbon, one you have to write, you don't have to write all of them. You can write carbon. Inert means unreactive. So these are the unreactive metal, platinum, carbon or graphite. Now copper is not a, copper is reactive relatively. As you can see, when we are doing electrolysis using the copper electrode, copper atom, the electrode can change. That's why we don't say that is inert. Inert means unreactive. So unreactive are only metal. In terms of metal, that is platinum, and in terms of non-metal, that is graphite or carbon. Then they're asking, write ionic half equation in which hydrogen is produced. So as we already wrote the equation for production of hydrogen, how hydrogen is produced, hydrogen ions gain electron, hydrogen ions gain electron, turn into hydrogen molecule. So we have to write the ionic half equation for this. So the hydrogen ions are there. When one is there, it will gain one electron, turn into hydrogen, but you always write for non-metals a molecule. So this will be the molecule. The next part, where is hydrogen produced? So which electrode hydrogen is produced, anode or cathode? As you can see, which electrode this hydrogen is produced. So it is produced at cathode, so we can say negative electrode, or you can also say cathode. Describe a test for chlorine. The test for gases that we will discuss at the end, means the next week we'll complete this topic and we'll discuss the test for the gases. That's why we'll skip this part. This question is about the chemical cell, and so what we have copper 2 sulfate was electrolyzed using the apparatus. So it contained copper ions, it contains sulfate ion, it contains hydrogen ion and hydroxide ion. So copper ions are attracted towards the cathode, so copper ion will gain electron, turn into copper atom, so size will increase. And for negative ion, hydroxide ions will move. Whenever hydroxide ions will move there, they will give oxygen gas. So basically we have to write a test for oxygen gas. That we will discuss next week, the test for the gases. Now during the electrolysis, electricity passed through the copper 2 sulfate solution. A solid copper 2 sulfate does not conduct electricity. Explain both statements. So solid copper 2 sulfate cannot conduct electricity, but solution can conduct. And it's of 3 marks. So what are the points we should include? First, solid copper 2 sulfate ions are not free to move. Ions can only vibrate. But in a solution, when it is dissolved or a solution, ions are free to move. That's why it can conduct electricity. So solid copper sulfate, it's an ionic compound. Cannot conduct. And why it cannot conduct? Because ions are not free to so 1 mark is for mentioning the first point is copper sulfate is ionic compound. That's 1 mark. And for ionic compounds in a solid state, ions are regularly arranged, so they're not able to move. But solution of copper sulfate, ions are free to move, so it can conduct electricity. That's how you'll score the 3 marks. Number 1, copper sulfate is ionic compound. Ionic compound in a solid state cannot conduct because ions are not free to move. But in a solution, ions are free to move. That's why it can conduct electricity. Now electrolysis was replaced using the copper electrode. The equations are given. Which species reduced during the electrolysis? Reduce means gain electron. So which species reduce? As you can see, the copper ion, they gain electron, turn into a copper atom. So that is copper ions at cathode. And why this is reduced? Because they gain electrons. Is it clear? The answer for C1. The question was, the two equations are given at anode and cathode. They are asking which species reduced. So the one which is reduced means the one which gain electron. So copper ions are there, they are reduced at cathode because they gain electron. And it's of 3 marks. The next, the mass of the copper electrode changes during electrolysis. So when we carry out the electrolysis using the copper electrodes, the size of the cathode, it increases and the size of the anode will decrease. So state and explain how and why the mass of two copper electrode changes. So what is the reason here? Because at cathode the ions change into atom and they stick to cathode. Whereas at anode the atoms change to ion. So the ions move from the anode, that's why the size is decreasing. And we have to write the equation. So copper ions are there, from the solution gain electron, turn into copper atom, that's why the size is increasing. And here what happened, the copper atom will go inside the solution as the copper ion, so the size is decreasing. Is it clear discussion? Any doubts? Why the mass of copper electrode changes during electrolysis? Any question or a doubt this part? So these are the questions. The last one is why during the electrolysis the color does not change. You will mention because the copper ions which go out from the solution is balanced with the copper atoms change to copper ion from anode. That's why the color does not change. So these are the questions related to the electrolysis. The 5.1 is done about electrolysis of molten and aqueous substances, and next session we'll do 5.2, which is about chemical cell. So I'll end this session and share this recording with you.